So this recording is meant to provide further explanation on the exit ticket for the composite functions when you're evaluating limits. So remember, g of x consists of a piecewise function in function notation, and f of x is our graphic representation here. So first of all, when we're evaluating the limit as x approaches 2 of f of g of x, we want to rewrite this first. So it would be f of the limit as x approaches 2 of g of x, and then we would evaluate the limit on the inside first. So we need to go up here to the top and evaluate the limit for g of x as x approaches 2. So when we're evaluating the limit as x approaches 2 of g of x, we need to plug in to the function that includes 2, which in this case would be the bottom. So when I plug this in, I end up substituting 2, squaring it to get 4. The opposite of 4 is negative 4 plus 1 is negative 3. So the inside, the limit as x approaches 2 of g of x is negative 3. So then what I want to evaluate is f of negative 3. So then I would go over to the f of x function and evaluate f of negative 3. There is no limit here. So f of negative 3, I go to negative 3 and I go down on the graph, and it's a little bit below negative 4. So we'll just approximate negative 4 1/3. Again, this is an approximation, so if you gave me a different decimal, I would have to take a look. Again, evaluating here. So we would evaluate g of the limit as x approaches 2 of f of x. So I'm going to go to f of x and evaluate the limit as x approaches 2. Now, because this is a graphic representation, I need to evaluate the limit from the right and from the left. So here I'm evaluating as x is approaching 2 from the right and from the left, and the approximate value is 1. So now this entire portion right here is equal to 1, so I want to evaluate g of 1. So then I go up to the g of x function and I look at this piecewise function. 1 is the breakoff point. This is where my function changes. Here, this function, this linear function, is for all values less than 1. This quadratic is for values all greater than 1. And when x is 1, y is 3. So my answer here is 3. Evaluating number 7. So this would be f of the limit as x approaches 2 of f of x. So the limit as x approaches 2 of f of x, we already found out up here in number 6, is equal to 1. So we want to evaluate f of 1. So I go up here to the graph. F of 1 is a whole, so the answer would be undefined, or basically it does not exist. In the last one, g of the limit as x approaches 2 of g of x. So I need to evaluate the limit as x approaches 2 of g of x. So we actually already did that up here, so I don't have to do any work, provided I knew what I was doing. So this whole answer right here is negative 3. I want to evaluate g of negative 3. So I need to go back to the g of x function, find out which function I use, or which portion of this piecewise I use when x is negative 3. It's the top. So I'm going to plug in 2 times negative 3 minus 1/3. So that's what I plugged in here. So this gives me negative 6 minus 1/3, or common denominator would be negative 18 over 3 minus 1/3. So this answer is negative 19 over 3.